Hello class, today we are going to talk about permutations and combinations. So first, what is that? A permutation. This is an arrangement of objects in which order is important. It matters. So for example, AB and BA are two different permutations. They have the same items in there, but they are in a different order, and so they count as different permutations. Okay, so let's just take a look at this. This is kind of what we've been doing before. So consider the number of permutations of the letters in the word July. So in how many different ways can we arrange all of the letters? How many different ways can we arrange just two of the letters? Okay, so we're just using the letters in the word July. Now these are permutations, so order matters. Okay, so let's see, part A. So what we have here, how many options do we have for the first choice? First choice times how many options we have for the second choice. Okay, we've been doing this before. Times how many options we have for the third choice. Times how many options do we have for the fourth choice? Because we only got four of them, right? So, well, for the first choice, we could pick any of the four letters, right? They're all good. For the second choice, we could do, well, we've already picked one, so we only have three letters left, right? So 3. For the third choice, well, we've picked two of them now, so we can only pick two more. And then for the last choice letter, well, we picked 3 of them. There's only one letter left, so times 1. All right? So we have 4 times 3 times 2 times 1. And so this means we have, let's see, it's 12 times 2 times 1. So 24 permutations. Okay? Part B. Same kind of thing, only here we're only using two letters. So we're going to have a first letter, and we're going to have a second letter, right? So how many different letters could we choose for the first letter? Well, there's 4 letters there, so we could have 4. How many letters could we choose for the second letter? 3, because we already wrote one of them down, so we've only got 3 left. So it's just 4 times 3. That's it, because we're only using 2 letters. So that would be 12 permutations. Okay? So let's take a look back here. So we have the expression, what we did, we had 4, 3, 2, 1, right? Right here, 4 times 3 times 2 times 1. And what that is, that can be written as 4 with this little exclamation point, which is read as 4 factorial. Okay? So factorial, what that means is whatever the number you have times every integer less than that number, every positive integer. Okay, there's one little catch to this, one exception, and that would be 0 factorial, which is 1. All right. So, for example, 5 factorial would be 5 times 3 times 5 times 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. You get it. All right. Why did we go into this? Because with permutations, the formula for that is factorial. So we had, a minute ago, we had 4 numbers, of which we wanted a permutation using all 4 numbers. And so the answer was that number 4 factorial, 4 times 3 times 2 times 1. Right? Like that. Now, sometimes we're not going to use all the numbers. Right? And this is a little notation we use for permutations. The first number, first subscript, that's how many numbers you can choose from. The second subscript is how many do you want. Okay? So here, number of permutations of n objects taking r at a time, where r is less than n. So what this means is we have n numbers to choose from, and of that we only want r of them. Okay? For example, in number 1, B, we had 4 letters to choose from, but we only wanted 2 of them. Okay, so that's what that second formula is for. And what this is NPR, so we have n factorial divided by n minus r factorial. So on example 1, we had 4 to choose from, but we only wanted 2 of them. So we had 4 factorial divided by 4 minus 2 factorial. Well, 4 minus 2 factorial, it would be 2. Minus 2, so we have 2 factorial, so we have 4 times 3 times 2 factorial over 2 factorial. And this helps to spread that out, okay? Whatever your factorial is on the bottom, or whichever one is bigger, really. Whichever factorial is bigger, just start listing that out until you get to the smaller factorial, okay? Because then you have 2 factorial over 2 factorial. Those are going to cancel out. They're gone. Just leaves you with 4 times 3, which equals 12, which is what we have here, right? All right. So there's that. Let's do another example. This time we're going to use the formula, okay? So we have 10 horses in a race. In how many different ways can the horses finish first, second, and third? Assume that there are no ties, okay? So what we have the number of horses in the race, 10. Okay, does order matter in this? Well, yeah. The person comes in first, it really matters if the other one comes in first the next time, right? You know, if I came in first, second, or third, it matters which one I'm in, because if I'm first, I get bigger prize money. So it matters. So this is a permutation because order matters. And I only want the top 3 because who cares about the rest of them? They don't get prizes. So what we have is, let's see what we had. N factorial, so that would be the number that we were choosing from. So that's 10 factorial over n minus r factorial. So that would be 10 minus 3. 10 minus 3 factorial. So let's see, that would be, I'm going to go ahead and put it 10 factorial over 7 factorial. The 10 factorial is bigger, so I'm going to break that down until I get to 7. So I have 10 times 9 times 8 times 7 factorial divided by 7 factorial. Well, I've got 7 factorial on the top and 7 factorial on the bottom, so those are going to cancel out. They go away. That just leaves me with 10 times 9 times 8. Well, 9 times 8 is 72 times 10 equals 720 different ways that you can have first, second, and third place out of just 10 horses in the race. All right? All right, let's take a look at another one. Move my camera down. Example 3, finding the probability using permutations. Okay, so we have a town parade. You're going to ride on a float with your soccer team. There are 12 floats in the parade, and the order is chosen at random. We want to find the probability that your float is first in the parade and the second float is the school chorus. All right? So, as you remember, probability is the number of favorable, okay? And does the order matter here? Yeah, the order matters because that's what it was. We want to know how many different ways we can do this. So the order kind of matters because we want to be first and the chorus second. So what we're going to have favorable permutations. Favorable permutations over total permutations. All right, so let's just stop to think about this. For this to work, how many different options are there for the first float in the parade? Well, there's just one. You and your soccer team have to come in first. All right. How many options are there for the second float in the parade? One, just the school chorus. That's it. Now, how many options are there for the rest? For the rest, after that, we really aren't that picky, right? So we could have any of the 10 other floats. Following that would be any of the 9 other floats. Following that, any of the 8 remaining floats. So after this, what we're going to have is 10 factorial for everything left. Right? Okay, so now let's see total permutations. Well, total permutations, that is all the possible combinations, right? All the possible different orders that they could put everybody in. So that would be 12 factorial because we're looking at everybody and we're using everybody. Right? So we have 10 factorial over 12 factorial. So we are going to break this down a little bit. That's just 10 factorial, and that'll be the smaller of my numbers. So 10 factorial over, and 12 factorial, I'm going to take that, I'm going to break it down because I have a smaller number on the top. So this would be 12 times 11 times, and now I'm to 10, so 10 factorial. All right. And I have 10 factorial on the top, 10 factorial on the bottom, so those cancel out, which leaves me with 1 out of 12 times 11, which is 132. And this is the probability of soccer first and chorus second. There it is. So not too bad. Not too bad. Let's take a look, see what we got over here. Got more stuff. Zoom out just a little bit. There it goes. Make sure it stays focused. Change colors. Let's see here. Count the possible combinations of two letters chosen from the list A, B, C, and D. All right, so let's just start listing off everything that we can, just using two letters, A, B, C, and D. So we could have A and B. Could have A and C. Could have A and D. Or we could have B and A, B and C, B and D. Could have C and A, C, B, and C, D. Could have D, A, D, B, and D, C. There you go. All the possible. However, we're looking at combinations now, aren't we? We are not looking at permutations. So we need to know what is a combination. And if we look down here, we see that a combination is an arrangement where order is unimportant. We don't care what order they're in, so AB and BA are the same combination. Same thing. All right. This is where we don't care what order they're in, we just care, did you get the same pieces? All right. And if you look at this, we've got some double counting here, don't we? Because those are the same combination. Let's put this down here. These are the same. And since these are the same, I only want to count one of them. I only want to count one of them. So I'm going to mark off one of those two. So let's see here. We've got, what other combinations do we have double counting? See, we have A, AB, and BA. So we'll mark off that one. AC and CA, those are the same. AD and DA, those two are the same. Okay, so let's see, we have BC and CB. We don't want both of those, we just want one of them. BD and DB, we just need one of those. And we see now that of all of these that we listed out, only 6 combinations remain. So there are 6 combinations. All right. So let's take a look at this. We have a formula that we can use for combinations. Let's move this down here. Formula for combinations. Okay. Combinations, since order doesn't matter, obviously we will never be using all of them. All right. For example, if I have 4 pins and I want to put them in any order, it doesn't matter, and they all count the same. That's the same combination as that, as that, as that. No matter how I put them, they're all the same combination. There's just one combination because I'm using everything and I don't care what order it's in. And it's only one way to get everything, and that's to use everything. All right. So we will always be having N and R. So we have NCR instead of NPR when it's permutations. So NCR, and what we have here is N factorial divided by N minus R factorial. So up to there, it looks the same, right? Same as permutations. However, what we're then going to do is multiply this denominator by R factorial. And what that's going to do, that's going to take out all of this double counting that we had here. Right? We had all that double counting, so multiplying that will get rid of it. So for example, we had A through D, so we had 4 different letters. We only picked out 2 of them. So 4 factorial divided by 4 minus 2 factorial times 2 factorial. So that's 2 factorial, 4 minus 2. So we want to get the same thing on the top. So 4 times 3 times 2 factorial, so those 2 cancel out. And then times 2 times 1. So 4 times 3 is 12, divided by 2, which equals 6. All right? Which is the same thing we did when we wrote down the sample space. So let's take a look at this using the combinations formula. You order a sandwich at a restaurant. You can order 2 sides to go with it. There's 8 sides, so how many different combinations of side dishes are possible? Do we care what order they put the sides on the tray? No, we don't care. As long as we've got the sides on the tray, who cares what order they were placed there? So this is combinations, not permutations. So let's see what we got here. We have 8 total to choose from. So we have 8 combinations, and we want 2 of them. All right. So equals, remind ourselves of the formula, and move that up. There it is. N factorial over n minus r factorial times r factorial. So n factorial is going to be 8 factorial over 8 minus 2, n minus r, factorial, times 2 factorial. All right, so there it is. Let's work this out. So 8 factorial, let's see, what are we going to have on the bottom? We're going to have, that's 6 factorial times 2 factorial. And here we're going to have 8. 6 is smaller than 8, so we will take this one and break this one down. This is 8 times 7 times 6 factorial. Now I have the same factorial on the top that I do on the bottom. So those cancel out. Gone. And 2 factorial, that's just 2 times 1, which is just 2. So that's easy enough to do. So this turns into 8 times 7, which is 56 over 2. And so my answer here is 28. So there are 28 combinations of sides. Combinations of side dishes. I cannot spell today. But I don't know what's going on with my fingers. They just do not want to write. Side dishes. There we go. Hideous, but whatever. All right. Now, let's find probability using combinations. Yearbook editor has selected 14 photos, including one of you and one of your friend, to use as a collage for the yearbook. They're all going to be placed at random, and there is room for 2 photos to sit at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Okay. So do we care what order our photos are at the top? No, don't care who's on the left, who's on the right, as long as it's you and your buddy at the top of the page. Do we care what order the photos are below us? Nope. Don't care. We just care that we're at the top. Right? So, order doesn't really matter here. Now, if you remember, probability is favorable over total. So we need to know how many total combinations are there. Now, what we're not looking at is how many total combinations are there for the entire thing. What we're looking at is how many different combinations can there be for those top 2 slots, right? So, there are 14 people to choose from, and we only want 2 of them. So, this is n factorial, so 14 factorial, over n minus r, so 14 minus 2 factorial times r factorial, so 2 factorial. Okay. So let's start working this out. We've got 14 factorial over, that would be 12 factorial times 2 factorial. Note, 12 factorial times 2 factorial is not 24 factorial. All right. So let's see, that's 14 factorial is the big one, so we're going to break that one down. So that would be 14 times 13 times 12. We got something that we got on the bottom, so 12 factorial. Over 12 factorial times 2 factorial. Well, that 12 factorial is going to cancel out because it's on numerator and denominator, so that simplifies out and it's gone, leaving me with 14 times 13 times 2, we're going to change that, times 1. All right. So 14 times 13 divided by 2 is going to equal 91. And what this is the combinations of top 2 pictures. All right. Combinations of top 2 photos. So this is how many different ways they can pick the top 2 photos. What is the probability that they pick you and your friend? All right. So probability of you and friend. Well, since we don't matter about order here, we don't care if you're first or friend's first, so that means there's really just one combination, you and your friend. 1. Out of how many total combinations are there? 91. So, probability of you and your friend being the top 2 pictures of this yearbook collage would be 1 out of 91. All right. So, combinations, permutations. Permutations, order matters, okay? Order matters for permutation. Who comes in first, who comes in second, who comes in third is very important. Those are permutations. Combinations, we don't care what order they are, we just care who's in the picture. All right? What dishes do they put on my plate? We don't care what order they were put in, those are combinations. Permutations, if you're using everything, it's n factorial. However many you have times everything less than that. If you're looking at not using everything, just want some of them, then it's n factorial divided by n minus r factorial. Okay, how many are you picking? Combinations is always going to be n factorial divided by n minus r factorial times r factorial. All right, and there it is. Hopefully you found that useful, and I will see you in the next video.